Today's show is sponsored by Do It. Cloud spend is just the surface. What really matters is how it drives performance, reliability, and speed to market. Do It Cloud Intelligence aligns every dollar to the intent of the workloads. Do It is trusted by companies like Fiverr, HackerRank, Current, and Superbet. Do It helps teams go beyond dashboards, surfacing hidden inefficiencies, resolving incidents faster, and aligning cloud operations with business priorities. One platform, unified signals, better outcomes across engineering and finance. Visit doit.com, that's DOIT.com, to unlock intent-aware FinOps at scale. Do It Cloud Intelligence. Today's show is sponsored by Vasion Print. Technology should drive your business, not slow it down. But legacy print systems are a resource suck. Don't waste time and money managing print when there's a solution. Vasion Print, formerly known as Printer Logic. Eliminate resource-intensive print servers and make the switch to an intuitive, cloud-native solution that makes printing effortless for IT teams and end users. Reduce attack surfaces and secure your environment while enjoying cloud-native flexibility that's easily supported in a hybrid workforce. It's not a patch or a fix. It's a truly seamless solution for print. See for yourself by scheduling a demo at vasion.com. That's VASION.com.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And this is an interesting topic this week because it's actually somebody I've been wanting to talk to for a long time, well known in the industry. And we talk about Kubernetes a good bit on the show, and we've been increasingly talking more about Kubernetes and AI and this intersection with GPUs, and we're going to dig into that a little bit more today. And for that, we have Haseeb Budhani, co-founder and CEO at Rafay Systems. Haseeb, how are you doing?
I'm good, my friend. How are you? Good to see you again.
Good. Give everyone a quick introduction, please.
Sure. My name is Haseeb. I work at Rafay. I'm the CEO here. We've been doing this for going on 7 years. What a crazy time. We were just talking before we started recording about the lives we live, where we are all traveling 3 weeks out of 4. And, we sort of love it. We sort of hate it. But no, what a great time to be working on AI, infrastructure, automation, and orchestration. And of course, we'll talk about that today. Looking forward to this.
So, first of all, I want to kind of dig into Kubernetes and talk about this evolution of Kubernetes as a platform. We've had this running joke on the show, and I think you've talked about it in the past before, that Kubernetes is almost at times like a platform to run platforms more than anything else, right? And we've seen some industry trends and shifts, and we've seen DevOps and we've seen platform engineering in recent years, and you've really positioned Rafay as Kubernetes operations and an operations platform that's now evolved into more of a cloud automation platform. So how do you, in your head, define that difference and think about, that difference between Kubernetes management and true platform engineering, if I use that term?
Yeah, interesting place to start. So here's the distinction I sort of call out. In fact, I'll tell you a story to explain the distinction. I've told this story before. January of 24, so 18 months ago or so, we had this strategy session with our board. And at the time, the board knew us as a Kubernetes management company. And we still do a really, really good job of that. But the first slide I had in the deck at the time was literally, this is not even, change history after the fact. Kubernetes is now furniture. Nobody gives an S anymore. And that's the first slide. And my board's like, we've given you a lot of money to do Kubernetes and you're telling us it's not important. What's up with that? And the point of that slide was for me to have an opportunity to have a real conversation with my investors and my colleagues to say, guys, look, the notion that these aficionados in Kubernetes who used to buy these kinds of products is gone now. It's done. Very soon, we're going to see a world where it just needs to work now. It needs to go away from these aficionados to people who run an operations environment for an enterprise or for a CSP. They will have 1,000 things to do. One of them happens to be Kubernetes. So if it's something that takes 20, 30, 40% of their time, they're not going to buy your product. It needs to be so simple and so operationally friendly They don't have to think about it anymore. It's furniture.
Yep.
That was number one. And the number two was, what is the most important use case going forward? So the most important use case at the time, at least that we saw, we had no customers doing that at the time. We had a hypothesis, was large enterprises will build private clouds for AI, and the traditional MSPs and the data center companies are going to want to compete with the CSPs and deliver AI in their regions. That was our hypothesis. And of course, by the grace of God, it's turned out to be absolutely on point. But then the intent was not, okay, let's just go sell them Kubernetes. So I see a lot of our competitors do this. Let's just sell them Kubernetes. Let's build a template. Let's build a palette or whatever. It's not bad at all. That's not what people are looking for. People are looking for an operating system for their private environments. Now, private could be in your data center. By the way, it can also be in Amazon. It's my private environment. How do I operate a private environment with an operations team that is already overburdened with so much technology? And you're going to come and tell me, I need to build experts for this now? Yeah, no. It needs to, again, going back to, it needs to be operationally friendly, simple to use. And that is a distinction with a significant difference. And we've invested heavily here. Right? We built a whole PaaS layer on top of our platform that you're familiar with, which makes it easy for the consumers of a platform to do their jobs. And the consumers are not just the ops people or the security people or the developers. It's all of them combined have a different experience that they expect from a platform like this. And what we need to do is empower the platform engineers to deliver those experiences. Ops guys need this. Developers need this. Security guys need this. FinOps guys need this. Stitch these together, deliver them as a service inside your organization, you're going to win. And we have enough data points now, by the grace of God.
Yeah. And let me ask you a kind of a follow-up question to that, because I think there's always been this concept of like, hey, we want quote unquote enterprise ready Kubernetes, right? And if you would have asked somebody a couple years ago, you might have had a certain definition of that. But based off of that conversation, as one example, what does enterprise Kubernetes look like in 2025 before we kind of flip over to AI and ML for a little bit?
So my favorite example of that, man, I can get you so many stories on that topic. The good part about my job is, man, I talk to a lot of customers daily. The bad part is this, I feel like I don't do my real job. Like I don't know. I feel like I'm a sales guy, but look, a few years ago, people, when they would say enterprise grade, they would focus on the vagaries of which CNI should I use. Yeah, it's not as important anymore because that specific part of the market has matured enough that it really at some level doesn't matter. This one versus that one, the real thing that matters, I'll tell you the number one use case for enterprise grade. I want, as a developer, I just wrote a piece of code. I want to press a button and I want a test bed. I don't understand Kubernetes. I don't understand ingress controllers. I just know that my application is Java-based or Spring. My company uses, MySQL as a backend and we use React as a frontend. This is the world I live in. Here's my code. Make it work for me. I press a single button. Everything's magic. So that's the expectation. If you can deliver that, you actually are ready to sell to enterprise. But when I press that button, turns out I have a manager. He's got a manager. They have to approve this. So I need a ServiceNow integration so that when that ticket is approved with ServiceNow, the process keeps moving forward. And if my code works and the test on it passes, I want that update to go back to my boss also. Okay, now we're talking enterprise grade. The most important investment we made is thinking about the workflows that drive business forward in a significantly faster way. They already do business, right? They already have a company. They've been doing this for a long time. How do their systems work? Many of them are standardized on ServiceNow, or I'm using that as an example. It could be whatever system. But if we have the ability to plug into their systems, firstly, the sale is easier, right? Going to production is faster, right? And nobody has to learn anything new. To me, this is enterprise grade. I don't think when people say enterprise grade, of course, there's expectations on security and operations and all those things, but it's about how do you operate in my world? And you have to give a very, very crisp answer of that.
Yep. I love that. That's a fantastic answer. Thank you very much. Let's kind of flip over to AI and ML because we want to talk about that in GPUs for a little bit. I've kind of had this thing in my head of like many developers and data scientists. They're they're not aware of the underlying platform they run on, and rightfully so. And I saw a stat recently that about 95% of AI runs on Kubernetes, either on-prem or in the cloud. And despite this, I would say platform teams are often stuck kind of with manual GPU provisioning, or things just aren't scaling the way it should, or it's your classic era of resource scheduling and efficiency around that, right? And so tell everyone a little bit of how does modern GPU orchestration solutions, how does that change the platform team's role? Because up until now, it's been hey, I just need to worry about compute, or I just need to worry about storage or networking. You almost have this entire new vector just around managing GPUs.
Yeah, totally. So if you think about the fact that so many of these enterprises are buying some very expensive hardware from NVIDIA and AMD, we're seeing the birth of so many neoclouds globally who are investing heavily hundreds of millions of dollars in all this infrastructure, right? There's a broad hypothesis in the market that if you deliver private or regional or sovereign AI environments, you will have consumption. Okay, so the developers who may come, maybe internal developers or external, the question is, what are they doing today? They're going to a CSP to consume this infrastructure, right? They go to Amazon, and that's the sort of the elephant in the room, right? They're going to somewhere and consuming this infrastructure. So when I talk to a new customer, I repeat the following every single time. I tell them that, look, your job now is to deliver a CSP-like experience to your users. So first, the question is, who's your user? You must be very clear on who your users are, internal, external, whoever. I need for you to show me a user story. In fact, we make this a requirement on the customers. If you don't have one, we're going to build one together. But my friends, you need to think like a product manager now. Not an IT team, a product management team. Who are your users? What are they looking for? Let's obsess over that. But then you need to understand that you have to deliver the same CSP-like experience that your developers, your data scientists are used to in a public cloud. So what do the public clouds deliver that you must deliver? So there's 3 things you must do. Number 1, it has to be actual self-service. You talk about manual provisioning. If I need whatever, I have a specific thing to do. I need 8 GPUs. And if I'm going to call you and you're going to say, okay, well, I guess I got to set it up, and oh my God, 2 weeks. No, this is not a cloud. Clouds must be self-service. I can go to console.aws.amazon.com and I can consume stuff. When I say Amazon, I don't necessarily mean just Amazon. I mean the CSPs in general. Of course. Right? I feel like Kleenex is, tissue, right? I need that experience. So that's number 1. Number 2 is if all you do is give me SSH access to a server with GPUs, yeah, man, that's not a cloud. That's not a CSP. There must be something on top. So you need to understand my needs. Do I need an ML workbench? Do I need a Jupyter notebook? Do I need just an inference endpoint and you give me a bunch of tokens, etc.? You need to have clarity on the consumption methodology. And number 3 is it has to be truly multi-tenant. My definition of multi-tenancy. You may have 2 users who show up at the same time. One may say, I need 64 GPUs. And the other may say, I may need 1 GPU. You need to be able to serve both ends of the spectrum. But 64 could be 1,000, whatever. Depends on, of course, how many GPUs you need. For 64, you may need to set up 8 servers for them. Usually HCX servers have 8 GPUs per server. But for the guy who wants 1 GPU, you need to have a methodology where within a server, where you may have 8 GPUs or 4, I only get 1. I don't know about the others, and nobody can see me. True multi-tenancy inside the cluster. Inter and intra environment multi-tenancy. If you cannot do that, you're not a cloud. But you're trying to be a cloud. You must have all of these 3 things be true. Of course, as Rafay, our pitch to the customers, we can do all these 3 things for you, and we actually can do that. But this is really important because a lot of people throw around the phrase cloud or CSP or, man, let's agree on the definition of these things. The definition is, I'll repeat it, self-service consumption of actual applications or workloads in a multi-tenant way. If you cannot do all 3, not a cloud. And by that definition, many of the clouds that we know today, public companies who are doing very well, they're not clouds. And that's always a fun conversation.
Yes. Yep. Now, let me add another aspect to the multi-tenancy, though, because one of the additional considerations, whenever I think of multi-tenancy, and I come from, an infrastructure-centric background, my head immediately goes to like security and is it just segmentation or is it something more? And so like especially with GPU workloads, really handling very sensitive data and the AI models and security just becomes so critical in this environment. How should organizations approach this security and compliance aspect and data sovereignty aspect in their GPU-enabled Kubernetes today?
Well, let's start with the definition of multi-tenancy there. I think that becomes important here, right? So if we start at the bottom of the stack, well, we got to think about the network first, right? So if I need 64 GPUs, which means I have 8 servers that need to be, let's use a generic word, partitioned, cordoned off from the rest of the network. I don't want to use the word actual multi-tenancy or isolation here. Okay, so that means that those 8 servers need to be able to talk to each other in an east-west fashion. Ethernet, maybe InfiniBand, right? So if it's InfiniBand, I need to understand what P keys are. Okay, then I have a north-south network. So I need to understand, okay, they need to belong to the same north-south network. So I guess we need to figure out how to manage VLANs. Okay, so now I got 8 servers. But let's say on these 8 servers are N servers. I also want to solve for a guy who needs one GPU. Okay, well, how does that work? So, okay, well, 1 GPU means that I need to figure out that there's 1 server in my pool of servers, which means I need to understand what a pool is. I need to understand inventory management, which turned out to be the hardest problem we solve in our platform, by the way, that nobody cares about on day one. Nobody thinks about this, right? But you know that if you have finite resources. Eventually, you're going to run out. How do you know who has what? What a fascinating problem. That doesn't really make a big difference in the CPU world because there's always lots of CPUs. But in the GPU space, if you run out to get the next batch of GPUs, it's going to take some time. So how do you manage this stuff? So, okay, all right, fine. So I got 1 server. I'm going to put 8 users, each with 1 GPU each requirement on 1 server. Okay, all right. But then on this 1 server, I need to make sure that there's segregation. Okay, so maybe we should run a network inside this. So we do a VXLAN network. So we do an overlay inside the cluster. Okay, then we lay a VM layer, which is something that we've spent a lot of time with NVIDIA on, and they've blessed our implementation for KVM. So we are not big fans of KubeVirt, by the way, not because it's not a good technology, but because we found that at significant scale, we found that it's not that great. We prefer KVM, old school, tried and tested, just deliver old school libvirt based VM. So we do that. Now on the VM, Kubernetes. So now we have to set up Kubernetes on top of that. Now in Kubernetes, it turns out that if you need a slice of a GPU, then that's a problem. So maybe we should think about vClusters. But then vClusters, we got to make sure that there's another layer of networking. So we actually create another quota and network limit model. On top of that, we use Kata depending on the situation, and we wrap the containers in micro VMs. On top of that, we will deliver an application. So now N number of things happen in the stack. There's a few other things happen inside this as well. The quota management has turned out to be a pretty hard problem to solve for us, actually. Now we're talking multi-tenancy, and I didn't touch one other thing, which is data. So now our customers are going to have, Veka, Vast, DDN, Pure. Pure is a new entry. At least we're seeing them now for the first time in some deals. So what we also did was we realized that our customers, once they have the solution that we tell them is great and everything, they still have to solve for storage. So we decided, you know what? We're just going to build a storage team in the company, and they're going to build integrations with all of the major storage vendors so that when my customer uses our platform, they get storage as a service out of the box. Okay, so now we can sell multi-tenant isolated storage if you work with Rafay, and we have 3 or 4 partners that we've already sort of, built integrations with. And this is our work. We did all the work, and we do it because we believe that it's important to our customers. So now we got the network layer, you got the compute layer, you got the storage layer. Now we're talking isolation. And then it comes to, okay, how do we prove it? Right? So particularly when it comes to a single GPU use case, we have built a very nifty little test case where if you use a standard Kubernetes model of namespace management, right, we can show you east-west lateral escalation like nothing, right? Just we can just pierce the layers. But if you use the stack that we built, it's impossible. I shouldn't say impossible is not the right word in security. It seems to be a really, really hard problem to solve, right? So we've thought a lot about this. And my colleagues have done a very good job of explaining this to a lot of our large customers. And look, we have enough NCPs, NVIDIA Cloud Partners, who use our platform, Buzz and Firmus and NISA and KKB and Yada, and enough customers now who use our platform, Indosat, who seem to be pretty happy. Will this stop? Are we gonna keep adding things here? Are we gonna keep improving this? 100%. The market's very early, right? We're also learning on the fly. But it seems that what we have already delivered is head and shoulders above everything else in the market, which is why we have the amazing customers that we have.
Love it. Love it. And it's super interesting too, when you're talking about all of this, like it always goes back to those original days of like, the origin of cloud. And it was like, what was cloud at the end of the day? It was like, well, reduce the friction up front, but also give the illusion of infinite capacity on the backside. Because at the end of the day, there's always a limit to the capacity somewhere. It's just you're hoping that those customers aren't going to reach it. And so it just seems like magic, right? And so what you're doing is really taking that and bringing that forward, which I love. Let me ask you this, though, because when we talk about developers and kind of having developers in self-service, it does make me think of one other aspect, though, in this kind of balance between dev and ops of, sometimes we always go back to all developers. They just want to ship software. They, they don't want to be writing YAML or doing some of these other things like managing clusters. And so like, there's always this delicate balance, if you will, of like the self-service capabilities, and then going back to that illusion of infinite control. Right? What you have to maintain control and governance, and because at the end of the day, that's what platform teams are going to be measured on, and how you keep up with all of this and project out, if you will. And so, how do you help the customers maintain that balance between the two?
So clearly, very important. Developers cannot run roughshod, but developers need to be able to operate in boundaries that are clearly defined. So the question then becomes, how do you set boundaries, right? So in our company, I always complain that we do a terrible job of naming things. So we just call it quotas and limits, which sounds so boring, but it's such a really important concept. Where, as an example, let's say an enterprise goes to a cloud provider and says, I want 100 GPUs. Okay, but they don't have one guy, right? They have multiple teams, each with multiple people. So now they have to think internally, okay, you take 10 and you take 20 and you take 50, etc. And then each of those teams will have people, right? So multiple levels of hierarchical management of quotas and being able to report on them and being able to prove that they're not soft quotas, right? I mean, there are hard limits set sometimes is really, really key. Every enterprise, every GPU cloud we spend time with, they have this expectation. In fact, this part of the stack, again, one of those boring parts of the stack like inventory management, ends up being the most important thing. Because without this, how do I run an infrastructure? How do I give the illusion, like you said earlier, that this is unlimited capacity? Although obviously it's not. It's really expensive and it's quite finite actually, right? These things work together to make sure that, yes, there's autonomy, but there's controlled, guardrailed autonomy for developers. They need to be told what the limits are. And once they are aware, they do their job quite nicely. And you can sit back and watch them, deliver revenue for the company. This mix is really, really critical. And the team here at Rafay has done a really good job of solving this problem.
I love that. And yeah, I've often used that analogy of guardrails, right? Just as that overlying catch-all of like, okay, how are we going to kind of protect the systems? You want to have a distributed system, but at the same time, you need to kind of put some protections in place for sure. So I'll kind of close this out there, though. I'll just kind of ask the last question. If anyone out there is interested, what's the best way that they could get started, Haseeb?
So feel free to reach out to us. All of us, including the engineers on the team, will receive your LinkedIn message if you send them, and they will show you how to get on the platform. Our website is rafay.co. Most people at this point in time with this company, unfortunately, maybe fortunately, don't sleep much, so we're always here. But no, the platform solves a real problem. We'd be delighted to have you try it and give us feedback. Always fun to get more people try it out and tell us how we can make it better. Looking forward to that.
Fantastic. Thank you very much for your time, Haseeb. And for everyone out there, thank you very much for your time this week as well. On behalf of Brian, who wasn't able to make it, and myself, we really appreciate it. If you enjoy the show, please tell a friend. Please leave us a review wherever you get your podcasts. And of course, that's it for this week, and we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.